Good morning all. I am Sivasakthti, working in Computer Science and Engineering Department in S.A. Engineering College. I am going to explain about some topics in data structures, and I am going to solve some problems on data structure based on stacks and queues. We'll go into the topic. So today's topic to be covered are introduction about stacks and queues and some gate questions based on stacks and queues. So stack is nothing but a linear data structure that follows last in first out principle. It means that we can insert an element at one end and the last element inserted will be the element deleted first. So that's nothing but last in first out principle. The last element inserted is the first to be popped out. It means that insertions and deletions will be done at only one end. So here's the diagrammatic representation of stack. So here we can insert an element into the stack, and the top element, the last inserted element, will be pointed by the pointer called top, and the element that is going to be deleted from the stack is nothing but the element which is pointed by the top pointer. And next queue is again a linear data structure where we can insert and delete elements from the, we can insert and delete the elements, but it follows first in first out principle. For example, a ticket counter. The person will move into the ticket counter, he'll get the ticket and he'll move out first. The same principle is followed in queue. It's nothing but first in first out principle. The first element inserted is to be the first element which is deleted first. So it is the ordered list in which insertions are done at one end, which is called as rear end, and deletions are done at the other end, the different end, which is nothing but the front end. So here's the example, diagrammatic representation of queue. So this is going to be the front end and this is going to be the rear end. So the elements will be inserted at the rear end, it will go to the first, and this will be deleted first. So next we will solve some problems based on stacks and queue. So here's the first problem. So here the first problem is given us some code. We need to solve that code, and we need to find the sum, the output sum, which is going to be given as the output for this particular code. So we'll solve first. So it's given as create an empty stack. So stack is nothing but a data structure where the insertions will be done at one end, which is nothing but the top, right? So here's the empty stack, and there are three variables, x, flag and sum. So x is initialized to 0, flag is initialized to 0 again, and sum, which is going to be the output variable, which is initialized to 0 initially. Right? Next, push x onto the stack. So x value is 0, that is going to be pushed onto the stack. So push in the sense we have to insert at the top end. The element pushed is x, so with the value 0. And next line, while s is not empty. So here's the condition, we have to check the condition. There is one element which is 0 into the stack, so it's not empty, the condition is true, so it will get inside the loop. And the next condition checks is if flag equal to 0. So flag is 0 here, so it's 0, which the condition is satisfied, so it will get inside the if part. And here the value of x is set as x plus 1. So actually the value of x is 0 initially, now it has been updated by adding 1 to that, so the now x value becomes 1. Now after we have to push it onto the stack. Already 0 is there, and one more element is added, which is nothing but x, whose values now is 1. And next condition, so this if part is getting over. Next it's checking another if condition. So if x is equal to 0, so x value is 1, which is not equal to 8, So x is equal to 8 is the condition. It's not equal, so this condition fails. So this statement will not get executed now. Next condition is if flag equals 1. Flag is actually 0 initially, so it's not equal to 1, so this condition is also getting failed. So this statements will not be executed as of now. So but still it's under the while condition. So while is not false yet, so it will get inside the while loop again. So now it will check while stack is not empty. Stack is not empty now. 2 elements are there now. So condition true, it will get inside. Flag equal to 0. Condition true. Again, the x value will be incremented by 1, and that will be pushed on to the stack. Now the x value is 2, and 2 will be pushed on. So the same continues till 8. X is equal to 8. The second condition is x equal to 8. So now the stack is nothing but, so 0, 1, 2, 3, 4, 5, 6, 7 and 8. Right? So this, now the x becomes 8. Right? So once the value x is pushed onto the stack, it will come to this condition if x equal to 8. This condition is true now. So the value of flag will be set as 1 now. So set flag equal to 1. So the flag value is 1 now. Next, if flag equals 1, the condition is true, so it will get inside, and now there is a pop. Pop of s. Pop is nothing but the top element will be popped, and that is stored inside the value x. So popped element is 8, right? Top is 8, so popped element is 8, and that will be stored in x. So already 8 is there, so the value 8 remains same. And next, if x is odd, pop. X is nothing but 8, which is even, so this condition fails, so pop will not be performed. Next, set sum equal to sum plus x. Sum is equal to 0 plus the value of x is 8. Again the while loop continues, and here the top element has been popped out. Now the top of the stack is 7, so stack is not empty, flag is not equal to 0, x is equal to 0, x is equal to 8. Again the condition satisfies, so it will get inside. Set flag equal to 1, already the flag is equal to 1, so again it will check flag equals 1, the condition is true. Again pop will be done. Pop is nothing but, now x becomes 7. Right? So top of the element has been popped out and it has been stored in the variable x. Next, if x is odd. Now x is odd, the condition is true now. Now it will perform a pop. Just it's performing a pop. It's not storing the popped element into another variable. So pop is nothing but one element will be popped out from the stack, which is nothing but 6, but it's not stored in any other variable. Next, set sum equal to sum plus x. So already 0 plus 8, that is 8 is there inside sum. Now x value is 7, so 7 will be added. Right? Then again, while x is stack is not empty, flag is not equal to 0, x is not equal to 8, flag is equal to 1. This condition satisfies, this is not satisfied, so it will get inside this pop s. Pop s nothing but 5. 5 will be popped, and that will be stored in x. So the x value is updated, and now it's 5. Next, if x is odd, so 5 is odd. 5 is odd in the sense we have to pop one element from the x, so 4 will be popped. Right? Sum equal to sum plus x. X value is like 5, so that will be added to the sum. Right? Then again loop continues. Flag is not equal to 0, x is not equal to 8, so these two conditions will be skipped. Flag equal to 1, which is true, x equal to pop, so 3 will be popped and it will be stored inside x. If x is odd, we have to pop one element. 2 will be popped, but it will not be stored anywhere. Sum equal to sum plus x. So already sum is 8 plus 7 plus 5. Now plus 3. Again loop goes on. Stack is not empty. Flag is not equal to 0. X is not equal to 8. But flag equal to 1. Condition satisfies. So pop. 1 will be popped and it will be stored inside x. X is odd, condition is true, so pop one element. So pop in the sense 0 will be popped out, sum equal to sum plus x plus 1. So again the loop goes on while S is not empty, but here the stack is empty. This condition fails now, so it will come out of the code. Now the value of sum is nothing but 8 plus 7 plus 12, sorry, 8 plus 7 plus 5 plus 3 plus 1, which is nothing but so the sum of the output of sum is nothing but this one. So the answer is 24. That is nothing but okay. So the value of the output of that code program is nothing but 24. Now we'll see the second problem. Consider the following sequence of operations on an empty stack. Now again here stack is going to be implemented. So we'll be having a stack. Right, now first operation is push of 54. Push is nothing but we have to insert an element into the stack. So the element is nothing but 54. So this is the empty stack. I'm going to push, so it will go here and it will settle here. So next push of 52. Again one more element, so elements will be added on, right? So 52 will be pushed. Now there are two elements. Now the third operation is pop. Pop is nothing but we have to take one element from the top of the stack. Top of the stack is 52 and 52 has been popped out and it has been deleted from the stack. Next again push 55. Now 55 will be pushed here. Next push 62. 62 will be pushed here. Next a pop operation has been performed. Pop in the sense 62 will be popped out and it is stored in S. Actually the previous pop we have popped 52 but it's not stored in any variable. But here after the pop operation the element has been stored in a variable called S. So now 62 element has been popped out, so it has been removed from the stack and it is stored into the variable called S, right? And second, consider the following sequence of operations on an empty queue. Now we are going to implement the following operations using queue. Queue is nothing but a data structure where insertions will be done at one end and deletions will be done at other end. So insertions at rear end and deletions at front end. So first operation is NQ of 21. So it will be inserted here but it will come to the front and it will stay here. Next NQ of 24. So 24 will be NQ and it will be stay here. And next DQ. DQ in the sense deleting. Deleting in the sense it will be done at the front end. So 21 will be deleted and it's not stored anywhere. Just DQ operation is not stored anywhere. So it has been DQ'd. So 21 has been DQ'd from the queue. It has been deleted. Next NQ of 28. So after 24, 28 will be stored. NQ of 32. After 28, 32 will be stored. Then again a DQ operation is going to be performed. DQ in the sense from the front element will be deleted from the queue. So front element is nothing but 24. 24 has been deleted from the queue and it has been stored in the variable q. So now q equal to 24 and this element has been deleted. Now there are only two elements into the queue, which is nothing but 28 followed by 32. So both stack and queue operation has been done. Now we have to find the value of S plus Q. The value S is nothing but the element popped from the stack. Q is nothing but the element dequeued from the queue. So here S and Q are there. By adding up, we'll be getting 86. So the value of S plus Q is nothing but 86. Here's the answer. Next question, we have to evaluate the postfix expression. The expression given is postfix. We have to evaluate. Evaluate in the sense we have to find the value of the given expression. The given expression is 10, 5 plus 66 slash asterisk 8 minus. So we have to find the value of this expression. The expression is 10, 5 plus 66 slash asterisk 8 and minus. So as we all know, the postfix expression is an expression where the operator will be followed by two operands. So expression in the sense we need, expression is nothing but a term where there will be two operands and one operator. So here postfix is nothing but the operator will be followed by the operands. So operator comes at the last, operands will be at the first. So that is nothing but the postfix. So as per that postfix, here is the first operand, here is the second operand followed by operator. So this is one term. So this will be like 10 plus 5. So if you convert this into postfix, this is nothing but infix, where infix the operator will be at the, operator will be in between two operands. Postfix is nothing but the operator will be at the last of two operands. Right, this is 10 plus 5, and again this is one operand, this is another operand followed by operator. So this will be given as 60 slash 6 followed by this star 8 and minus. This is, will take as such. Now it's nothing but 10 plus 15 is, 10 plus 5 is 15. Here 60 divided by 6 is nothing but 10 followed by star followed by 8 followed by minus. Right, now here is first operand, here is second operand followed by operator. Now it will be like 15 star 10, and here 8 minus remains as such. Now 15 star 10 is nothing but 150, 8 and minus. Now operand 1, operand 2 followed by operator. So this will be like 150 minus 8, which is equal to 142. So for the given postfix expression, we have evaluated and the result is nothing but 142. We'll check the result. The answer is 142. We'll go on to the next problem. So here is the problem. Consider a sequence of elements. So 5 elements are given and 5 elements are having some values like 1, 5, 7, 8 and 9. And the following operations are performed on a stack and a queue. Here both are involved. One stack and one queue are there, both of which are initially empty. So the stack initially we have like initially we have one stack and we have one queue, right? So here the elements are, first operation is push the elements of A0 from A5 into the stack in that order. Order is A0, A1, A2, A3, A4, A5. So we have to push the elements into the empty stack as per the order. The order is A0 is nothing but 1, next A1 is 5, A2 is 7, A3 is 8 and A4 9, A5 is 2. So this is the stack after inserting all the elements, after pushing the elements. Second operation is NQ the elements from A0 to A5 into that order into the queue. This is the queue. The elements will be inserted. So first element is A0. So 1 comes here, followed by 5, followed by 7, 8, 9 and 2. So this is queue and this is stack. So first 2 has been done. Third statement is pop an element from S. Pop in the sense we have to remove an element from S. So 2 will be removed. So here 9 is there. Next, DQ an element from Q. DQ is 1 will be DQ'd. Pop an element from S. 9 will be popped. DQ an element from Q. 5 will be DQ'd. Next, DQ an element from Q and push the same. So we have to DQ. 7 will be DQ'd. 7 will be DQ'd and that will be pushed onto the stack. Right? Next, repeat operation 7 3 times. 7 in the sense we have DQ an element and push the same. We have to repeat 3 times. So 3 times. First 8 has been DQ'd and 8 has been pushed onto the stack. 9 has been DQ'd, 9 has been pushed onto the stack. 2 has been DQ'd and 2 has been pushed onto the stack. So 3 times has been repeated. Next operation is pop an element from S. Pop in the sense 2 will be popped. And again pop an element from S, 9 will be popped. Now, so all the operations has been done. Now we have to return the top element of S after executing the above operations. So after executing all the above 10 operations, the top of the stack is nothing but 8. This is the answer for this problem and we'll check the answer. So the top of the element after executing these operations is 8. Next question. Consider the operator precedence and associativity rules for the integer arithmetic operators given in the table below. Here's a table where some operators have been given and the precedence of those operators also be specified and the associativity is also been specified. Now we have to find the value of the expression. So and the expression is 3 plus 1 and the expression is 3 plus 1 plus 5 stars. So we have to evaluate these expression. This expression is going to be evaluated by using the precedence and the associativity given. Right? So now the highest, so only 4 operators are there in the expression. The operators are plus, minus, asterisk and slash. So out of these operators, the highest precedence is given to plus. So as per this question, the highest precedence is given to the operator plus. High precedence is minus and medium precedence is for asterisk and low precedence is for a slash. Now we will consider the left associativity and we'll solve this expression. So here highest precedence is plus. So we have to solve the operator plus first. So 3 plus 1. So it is left associativity. We have to solve the expression from left for considering plus alone. So 3 plus 1 is 4. 4 plus 5 is 9. So after executing the plus operator, the result is 9. So asterisk is as such 2 star 7. Sorry. Next, again plus operator is there. 7 plus 2 is 9. Minus 4 minus 7 minus 6 slash 2 is as such. Next precedence is given to minus. So minus is right associativity. We have to solve the minus operator from the right. So here 9 star 2 is as such. Now here, so actually this is 7 minus 6. Okay. So here 3 minus operators are there in the expression. We have to solve from the right. Rightmost minus is for 7 and 6. 7 minus 6 is 1. So 9 minus 4 minus 7 minus 6 is 1. This slash 2 is as such. Again 2 more operators, minus is there. So now we have to follow the right associativity. 4 minus 2. So 9 star 2 slash 9 is there. Minus 4 minus 1 is 3 slash 2. So again 9 minus 3 is nothing but 6. So the expression is 6 slash 2. Now only 2 operators are there. One is star and slash. Out of this, star is having the medium priority. So we have to evaluate star first. So the expression becomes 18 slash 6 slash 2. After evaluating this asterisk, then at last we have the slash operator. Slash operator's associativity is right. So here there are 2 slash operators. So right associativity in the sense we have to evaluate from right. So 18 remains as such. Slash will be there. 6 bar 2. 6 slash 2 is nothing but 3. Now by evaluating this expression 18, so we'll be getting 6. So the value of the given expression by following these precedents and associativity, we are getting 6. We'll check the answer. The answer is 6. Right? And next question, convert the prefix expression into an infix expression. So infix is given, we have to convert, prefix is given, we have to convert that prefix into infix expression. The expression is minus asterisk plus ABC star minus DE plus FG. So given expression is prefix. Prefix expression is nothing but the operator will comes first followed by the operand. So we have to check where 2 operators that is followed, where 2 operators is going to be followed by the operator. Now here we have 2 operands. Before that we have 1 operator. So we'll be like taking it as minus asterisk. We'll solve this in this prefix. So this prefix will become as A plus B. Right? Other thing as such, star, C star, so we'll solve this also. Minus DE. This will become as D minus E. Right? And this will also be converted into infix. So this will become as F plus G. Right? Now 3 parts of the given prefix has been converted into infix. Now, so this is C. Right? Now here 1 operator, this is operand 1, this is operand 2. So by converting this, we'll be getting it as A plus B star C. Now this has been converted. Right? Remaining thing. Here 1 operator, operand 1, operand 2. So operand 1 will comes first, D minus E, right? Followed by operator, followed by plus G. Right? So after converting this, now this is going to be the operator, this is going to be operand 1, and this is going to be operand 2. By solving this, we'll be getting it as A plus B star C. Operand 1 is given, operator is minus, operand 2 is D minus E star F plus G. So this is the given, this is the infix expression of the given prefix expression. It's nothing but A plus B star C minus D minus E star F plus G. We'll check the answer. So here's the expression: A plus B star C minus D minus E star F plus G. So next question. There are 5 items P, Q, R, S, T are pushed into a stack one after the other starting from P. So here again a stack is going to be used. So you know the stack data structure. Stack is nothing but the data structure where the elements are inserted and deleted at one end. So elements are P, Q, R, S and T. So we have to push it onto the stack as per the order. So P will be here, Q, R, S, T, right? And next the stack is popped 4 times. Stack is popped 4 times and each element is inserted into a queue. And here one more queue is involved where the elements are inserted, and those elements are the elements which is popped from the stack. We have to pop 4 times. First time pop, T will be popped out, that will be inserted here. S will be popped out, that will be inserted here. R will be popped out, that will be inserted here. And Q, it comes here. Now 4 times the stack has been popped and those elements are inserted in the queue. Then 2 elements are deleted from the queue and pushed back onto the stack. Now stack have only 1 element, queue have 4 elements. Now we have to delete 2 elements from the queue. 2 elements should be dequeued from the queue and pushed back onto the stack. So elements should be deleted at this end. So first element deleted is T, that will be pushed onto the stack. So T comes out. The next S will be deleted and that will be pushed onto the stack back. So now one item is popped from the stack. So now after pushing, we have to again perform one more pop. So S will be popped out. One item is popped from the stack. Now the popped item. What is the popped item? Popped item is nothing but S. This is the answer of this question. So we'll check the answer. The popped item from the stack is S. Right? We saw some. We have shown some problems based on stacks and queues, and I'll meet you in another session. Thank you.